Welcome to everybody from the channel CIVIL-MECH-MATHS Concepts. In this particular video, I will be talking about CAT GRE GMAT Quantitative Aptitude problems, especially number system. And when we are dealing with reminders, how to deal with reminders. Regarding the factorials, I have already explained in one problem, one example was given, and to appreciate different types of problems and how the concept behind them to find the remainder is there. I have taken another example, which is a very good example, 77 to the power of 77. It's a very big number which cannot be done by human beings with hands. And when 77 to the power of 77 is divided by 777, what will be the remainder? It's not 1, it's not 0, the remainder is unimaginable number. And to solve this, we have to use prime numbers, factorization of the integers, and also the congruence, modulo, Chinese Remainder Theorem, remainder theorems are to be used. I will explain one by one, develop the concepts. After this particular lecture, I have given a brief about in my first lecture about number system. What type of numbers are available? A huge number system, real number system, complex number system, quotient number system, rational number system, irrational number system, integer system, natural numbers, whole numbers, everything I have discussed. In the next class on number system, because I have given the brief how the numbers are used and what type of problems we will come across and how to solve them. One or two examples I have done at the level of CAT and GRE and GMAT. Now, I will start the real syllabus from next class onwards by defining what type of different numbers are used in number system, because there is a greatest integer number, there are exponential numbers, there are logarithms, there are numbers within the interval, open interval, closed interval, semi-open interval, semi-closed interval. All these type of numbers one by one we will discuss. Once you know about the notation, how a number is looking like and how that number can be utilized in mathematics, then it will be easier for you to solve any type of problems given in the number system or any other system in the examination. And another thing, what is the absolute value of the number? What is the greatest integer value of the number? These things I will be discussing in the next class, maybe for 3-4 classes afterwards also. Understanding the numbers and number system is very, very important for the solving questions, especially in the higher mathematics level examinations like CAT, GRE and GMAT. Let us appreciate this particular problem. I will be taking a problem, solving it and explaining the concepts. You please see the video till the end so that you will get all the concepts together with you. You can write a notes and make it available for you for a revision. And if you want, you can repeat the video and understand the concepts. Let's go further. What is the question here? Find the remainder when 77 to the power of 77 is divided by 777. Because all 7s are there, don't expect answer to be 1 or 0. The answer is unimaginable, as I told you, different. Solution. Let us take denominator. That is equal to 777. Can we factorize it? Let us see. We can divide it by 7. 7 into 111. Can 111 have any other factors other than 111 and 1 itself? Is it a prime or not? 111, when you divide it by 3, let us go from it's a odd number, it's not an even number, cannot be divided by 2. The next odd number after 2 is 3. When you divide it by 3, 3 3s are 9, 3 3s are 9 and 3 7s are 21. That means this can be 7 into 3 into 37. These are the factors. 37 is a prime number. We have to stop factorization till we get the prime number. The factors are 7, 3 and 37. That means we should have for each number modulo. Modulo, I have already explained you what is modulo. Modulo. Or we can even rather say mod. What is required? This is about the denominator. Now let us go to numerator. Analyzing numerator and denominator, because these are all huge numbers, not single digit or double digit numbers. They are powers to the double digit, 77 to the power of 77. Here it is 777. Numerator 777 is factorized and we kept it aside. We have to test because it is having 3, 7, 3 and 37 as factors. We'll use mod 3, mod 7 and mod 37 because we have to divide by 7. 7 numerator should be divided by 7, divided by 3 and divided by 37 separately, because this particular denominator has got 3 factors. We have to divide the numerator by the factors of denominator separately. Now, numerator can we simplify? Numerator 77 to the power of 77. Let us keep it as it is, and is to be divided by 777 previously. Now, after finding the factors, 77 to the power of 77 is to be checked for behavior of division by all factors of 777. That means the behavior of 77 to the power of 77 is to be studied when it is divided by 3, when it is divided by 7 and when it is divided by 37, because 3, 7 and 37 are the factors of the denominator 777. Now, for 77 to the power of 77, first let us analyze 77. Afterwards we will go to the power of n. What is 77? 77 is equal to 25 into 3 plus 2. Do you agree? or 77 can be 78 minus 1. Do you agree? That is equal to 3 into 26 minus 1. That means 77 can be written as 25 into 3 plus 2, or 77 can be written as 26 into 3 minus 1. In both the cases, here in this case, when in 77 case remainder is 2, in 25 into 3 remainder is plus 2, in 26 into 3 remainder is minus 1. We can put either way. This can be represented as, this can be written as 77 equivalent to 2 mod 3. That means when 77 is divided by 3, there is a remainder of 2. This can be written as 77 equivalent minus 1 mod 3. Do you agree? That means when 77, 1 is added to it, then 78 is totally divisible by 3. Either way, both are same. Both give the result of 77 only. Are you able to follow? What is its ultimate answer? 77 plus 1 equivalent 0 mod 3. That is 78 equivalent 0 mod 3. That means when 78 is divided by 3, the remainder is 0. Here what it means? 77 minus 2 equivalent 0 mod 3. 75 equivalent 0 mod 3. The other way of representing these mod congruences. Now, we will take this one. We agree that 77 equivalent minus 1 mod 3, because 77 plus 1 minus 1 comes to this left hand side, means 78 equivalent to 0 mod 3. 78 is fully divisible by 3, which implies 77 to the power of n mod minus 1 to the power of n mod 3. This is a property of the mods. Modulo, congruence modulo equations. This is the property. Please remember this. When some value equivalent to some value of mod some value, when you take the powers of it, right hand side and left hand side, the remainder also goes to the power, and also the real number also goes to the power, and mod 3 is only divisible by 3. Mod 3 is nothing but it is a sentence, so that it will not change. It will not change in both the cases. Now, can we write like this? 77 to the power of 77, which is required numerator, equivalent to minus 1 to the power of 77 mod 3. Can we write like this? Minus 1 to the power of odd power is minus 1. Minus 1 into minus 1 is plus 1. minus 1 into minus 1 into minus 1 is minus 1. Minus 1 to the power of 77. It's an odd number, it is minus 1. Then it implies 77 to the power of 77 equivalent minus 1 mod 3. This is one equation. Or it can be, instead of minus 1, as I told you, you can use 2 also. Minus 1 can be replaced by 77 to the power of 77 equivalent to mod 3. Please try to understand this step, it is very, very important. Here minus 1 and minus 2, when you have reduced it to minus 1 and minus 2, you are not again powering it. The numbers and mod are remaining same. Minus 1 is replaced by plus 2 because this and this are both are equivalent. Similarly for power also, whatever may be this value, this is when you are not changing this value and this, minus 1 can be changed to plus 2 because of the previous condition. Okay. Now regarding mod 3 we have done. Next is with respect to mod 7, because there are 3. One is 3 into 7 into 37. Now we have to resolve about mod 7. When any number 77 to the power of any number like 77, this is the heading mod 7. 77 is equal to 11 into 7. That means remainder is equal to 0. That implies 77 equivalent to remainder 0 mod 7. Do you agree? Because 77 is divisible by 7. It implies when you power it to any power, 77 to the power of 77 equivalent 0 to the power of 77 mod 7. 0 to the power of n is equal to 0. This implies 77 to the power of 77 equivalent 0 mod 7. Now, next factor for 777 is 37. Mod 37 is to be analyzed. We are analyzing all the 3 factors. Denominator, all the 3 factors. With respect to the numerator, we are finding the behavior. 77 is equal to, because numerator is to the power of 77, 37 denominator is 77, 37 into 2 plus 3. Do you agree? That implies 77 is 3 mod 37. Do you agree? When 77 is divided by 37, there is a remainder of 3. Now, what are the 3 results we have got? I am explaining it slowly for your understanding. I don't want to hurry. I am not solving a question paper. I am developing a concept within you. Please bear with me. Now, here what we have got? 77 only we have got. 77 equivalent 3 mod 37. But what we require is 77 to the power of 77 equivalent to what? Mod 37. This will be 3 to the power of 77. Equivalent to 3 to the power of 77. Because remainder to the power, the same power we have to make, mod 37. Then what is 3 to the power of 77? 3 to the power of 77 is equal to 3 to the power of 20, not 20, what we have to do? 3 to the power of 72 into 3 to the power of 5. What is 3 to the power of 72? 3 to the power of 36 whole square into 3 to the power of 5. Here I want to explain one theorem applicable to find 3 to the power of 36. 3 to the power of 36 is equal to 3 to the power of 37 minus 1. 37 is a prime. And 3 and 37 are co-primes. If that is the condition, then for example, let us say there is a rule, there is a theory, there is a formula, you please remember, a to the power of p minus 1 equivalent to 1 mod p, where this is a very important theorem, where p is prime, a and p are co-prime. A is an integer. Here 3 to the power of 36 is equal to 3 to the power of 37 minus 1. That implies 3 to the power of 37 minus 1 is in the form of a to the power of p minus 1 in the above formula. It is a to the power of p minus 1. It is like equivalent to 1 mod 37. Do you agree? Because it is 1 mod p. Here p is 37, p is replaced by 37, a is replaced by 3. This implies the rule is 3 to the power of 37 minus 1 is 36, 3 to the power of 36 is 1 mod 37. Therefore, 3 to the power of 36 whole square is implies 3 to the power of 36 whole square is equivalent to 1 whole square mod 37. Mod 37 will not change. Only right hand side values get the power and also the remainder will get the power. That implies we will replace this value in the equation. 3 to the power of 77 is equal to 3 to the power of 77 equivalent to 1 square into 3 to the power of 5 mod 37. In this equation, we have used this value 1 square mod 37. 1 square is 1. That implies 3 to the power of 77 is equivalent to 3 to the power of 5 mod 37. What is the value of 3 to the power of 5? 3 to the power of 5 is equal to, that implies 3 to the power of 77 is as good as these two we are relating 77 to the power of 77. That implies 77 to the power of 77 is equivalent to 3 to the power of 5 into mod 37. What is 3 to the power of 5? Is 243. But 3 to the power of 5 is equal to 243. When you do it with mod, when you divide with 37, what happens? 3 to the power of 5 is equal to 243. That is equal to 6 into 37 plus 21. This implies 77 to the power of 77 is equivalent to, because 21 is the remainder, it is a multiple of 37, 243. Instead of 3 to the power of 5, we will replace with the remainder 21. 21 mod 37. What are the three equations we have got? First equation is 77 to the power of 77 is equivalent to 2 mod 3 when mod 3 is considered. 77 to the power of 77 is equivalent to 0 mod 7. Third is 77 to the power of 77 is equivalent to 21 mod 37. We have to combine all these three and get the answer. We have to combine all these three. How to combine them? Because this mod 3, mod 7, mod 37, these 3 into 7 into 37 is 777. So that we can get the remainder when you use the Chinese Remainder Theorem, CRT. We can apply that and get the answer with mod 30. Now let us see. To link in CRT, what we have to find out is that whatever 777 in the denominator is there, that should be divided by each factor. First is, when 777 is divided by the first factor 3, the answer is 259. When second it is divided 777, because these are all factors, they are divisible. 111 is the answer. 777 is divided by 37. The answer is 21. These are the answers when they are divided with reminders 0. Whatever we get, the coefficients 259, 111, 259 into 3 is 777, 111 into 7 is 777, 21 into 37 is 777. Whatever these values we have got, coefficients, we have to see the procedure, CRT procedure, Chinese Remainder Theorem. 259, how it can be written in terms of mod 3? 259 is equivalent to 1 mod 3. Do you agree? When you divide 259 with 3, 3 8 are 24, 3 6 are 18, 258. 1 is the remainder. When 111 is divided by 7, what will be the remainder? 6 will be the remainder. 6 mod 7. Just see, 7 1s are 7, 7 5s are 35, 105, that 6 is the remainder. Similarly, 21, how it will be written? Here, 21 is less than 37. Hence, better to go for inverse, modular inverse, which I have explained in the previous lecture. Please see that for further understanding. Modular inverse, how we have to apply? (21) to the power of minus 1 equivalent to some value x into modulo 37. That implies 1 equivalent 21 into x modulo 37, mod 37. That equivalent 21 into x, that x value, how much it should be when divided by 37. That can be, you just check whether 1 modulo 21 into 30 mod 37. Just see. Let us see. 21 into 30 is equal to 630. 630 minus 1 is equal to 629. Divided by 37 is equal to 17. Yes, it is correct. That means 21 inverse modulo 30 mod 37. Now, we have 6 equations with us. First equation is 77 to the power of 77 equivalent to 2 mod 3. Second equation is 77 to the power of 77 is equal to equivalent to 0 mod 3. Zero mod 7, sorry. Third equation is 77 to the power of 77 is equivalent to 21 mod 37. This is one set of equations. Another 3 equations are 259 equivalent to 1 mod 3, 111 equivalent to 6 mod 7, and sixth one is 21 inverse equivalent to 30 mod 37. Now we have to combine all the 6 equations and get the total value of Q, where 777 to the power of 77 is equivalent to some Q into mod 777. That's what we have to get. These are the 6 equations. In this, mod 3 remainder is 2, mod 7 remainder is 0, mod 37 remainder is 21. When 777 is divided by mod 3, the remainder is 1, mod 7 remainder is 6, mod 37 remainder is 30. Now we have to combine all these and we will write Q value as 2 into 259 into 1 plus 0 into 111 into 6 plus 21 into 21 into 30. That value is equal to 13,748. Here, this 30 is the remainder and here I will write one by one for your clarification. I will give the how we have used this formula and how it has got. Because when 777 is divided by 770, this value is 777 by 3, excluding all these values remainder. This value is 777, the denominator divided by 7. This value is 777 divided by 37. All these are excluding remainder. Excluding remainder. Here also it is excluding remainder. Please understand this. Because why there is an exclusion of remainder? These are all factors. When factors are there, remainder is 0. These are all factors. When denominator These values are pertaining to denominator. These values are pertaining to denominator. The first value is pertaining to numerator. What is the numerator equation in this? Remainder is 2. It is the remainder in the numerator. It is the factor in the denominator. This is factor denominator. This is factor denominator. This is remainder numerator. This is remainder numerator. This is remainder numerator. For this number, this is the remainder. For 259, 1 is the remainder. For 111, 6 is the remainder. For 21 inverse, 30 is the remainder. With this, first remainder in the main number, that is numerator, multiplied by factor in the denominator into remainder in the factor of denominator. Please try to understand this complex equation and solve any type of problems if they come like this. Now, if you want to cross check, divide 13,748 divided by 777. 17 plus 539 remainder. Hence, when this is wrong. 77 to the power of 77 is equal to. Because this can also be written as we have started, 13,748 is equivalent to, what is the value? 539 mod 777. Hence, this 13,748 is replaced by 539. That means 77 to the power of 77 is equivalent to 539 mod 777. This is the answer. I know this problem is a lengthy problem. It's a difficult problem to crack, but still I took it so that you will understand the concepts. Once you understand the concepts, any question that comes, a simpler question may come in the examination, you will be able to answer it very easily. I will go through the procedure once again for the benefit of everybody. The question is, what is the remainder when 77 to the power of 77 is divided by 777? In this, numerator is 77 to the power of 77, it's a very huge number, and 777, it's also a 3-digit number. When we have taken the denominator, we have found that 777 has got 3 factors, So, the Chinese Remainder Theorem for multiple factors is to be applied. Numerator is 77 to the power of 77. Denominator is only for finding the factors. Numerator for really solving the problem. 77 to the power of 77 we have to simplify. That is equal to 77 is equivalent to minus 1 mod 3. Then we have taken power up to 77 to the power of 77. Then that has come to minus 1 mod 3. That is equal to 2 mod 3. Whether it is minus 1 mod 3 or 2 mod 3. We have taken the value of 2 mod 3. And when you take the value, because that is mod 3 we have solved previously, because 3, 7 and 37 are the factors. First factor 3 is taken and found that 77 to the power of 77 is equivalent to 2 mod 3. In terms of mod 7, 77 to the power of 77, because it is divided by 7, remainder is 0, that's equivalent to 0 mod 7. Then when you come to find relation with the final factor, that is 37, 77 is equal to 37 into 2 plus 3, that is 77 is equal to 3 mod 37. Now 77 to the power of 77 is 3 to the power of 77 mod 37. Both sides the values are powered to 77. 3 to the power of 77 is nothing but 3 to the power of 72 into 3 to the power of 5. 3 to the power of 72 is nothing but 3 to the power of 36 whole square into 3 to the power of 5. Why we have taken in terms of 3 to the power of 36? Because we want to apply the rule a to the power of p minus 1 equivalent to 1 mod p, where p is the prime, that is 37, a is the number, that is 3, 3 and 37 are co-primes, and p minus 1 is 37 minus 1 is 36, so that it becomes simpler. That means 3 to the power of 36 is equal to 1 mod 37. Now 3 to the power of 77 is equal to 1 square into 3 to the power of mod 37. 3 to the power of 5 is nothing but 243. 243 is equal to 6 into 37 plus 21 as the remainder. Hence 77 to the power of 77 is equal to 21. It is not 77, rather we will make it as 77 to, because 77 to the power of 77 is equal to that is equivalent to 3 to the power of 77, which we have already proved. That 3 to the power of 77 we have substituted, so that it has become 21 mod 37. Now 21 being a number which is lesser than 37 and also mod 3, this 259, when they are divided by individual mod numbers, 777 divided by 3 is 259, 777 divided by 7 is 111, 777 by 37 is 21. This 21 don't compare with the 21 of other. This 21 is less than the mod value. Hence we have applied the modular inverse formula and we got the values. And when we have got the values, we have not taken modular inverse everything into consideration. We just multiplied 259 into 1 into 2, 0 into 11 into 6, 21 into 30 into 21, that we got 13,748. That 13,748 is divided by 777. Then we got 539 as the remainder. Hence 77 to the power of 77 is equivalent to 539 mod 777. It's a lengthy procedure, but any question can come which involves, may not be all the theorems. The question may be from CRT. The question may be from a to the power of p minus 1 equivalent 1 mod p. A question can come combining all factors, congruences, how you combine them, and interrelations. If the whole problem may not be given, any one of these may be given, so that you should be able to answer them in finding the remainder. This is one of the biggest problem in remainder theorem, modular inverse also. It is a very big problem in modular theorem, so that this modular, inverse, congruence, interrelations, and this a to the power of p minus 1 equivalent 1 mod p and CRT, if you are thorough, then you can handle any question that is being given in the examination. With this, I want to conclude. Best of luck to everybody. Thank you for listening to me. And it's a very lengthy lecture. Please listen to it fully. If you don't understand, please comment. I'll answer. And please listen to it fully and understand it. Once you understand, then you can answer the questions very easily. Best of luck. Thank you. And if there is a value addition to your knowledge because of this lecture, please subscribe to my channel, CIVIL-MECH-MATHS Concepts, and share and subscribe. Share my channel details and subscribe to my channel. And these questions are given out of my interest to thrust upon the different concepts and different methods. Whatever methods we apply here, they are not generalized rules. These are concepts only. These cannot be applied in each and every problem. You have to understand the problem. Whatever part of the concept is applicable, that part only you apply. That's a caution to be taken. Thank you.